Okay, hello guys. Today our topic is about orbital speed. Just we are talking about the motion of the satellite or some planets around the sun and around the planet. Okay, so let's move to this part. It's very interesting. It's about a kinematics part and with astronomy part. Okay, so let's move to the first part about orbital speed. Okay, so most of the planets and satellites around maybe the sun or maybe the planets, and you can find the orbit is a circle, right? So then we can consider it as using the circle parameter formula. Okay, so we all knew that that the parameter for the circle is like 2 times pi times the radius, right? Okay, so parameter here, sorry, okay, parameter here equals to 2 times pi times the radius, right? I think not very difficult for you. So if you like a satellite here, just turn around and just moving as a circle and to form a loop, right? We can say, oh, maybe here the parameter for the circle equals to 2 pi r, right? This means the distance moving for the satellite, right? This is the first part, okay? The distance moving. And if you have a time taken, you can say, oh, here the speed equals to distance over time taken. Here speed equals to distance over time. Okay. So for here, distance equals to 2 times pi times radius. You can just put into the formula, and it can becomes velocity equals to 2 pi radius over time taken. Okay. So this is for velocity. I think it's not very difficult for you. Okay. Velocity equals to 2 pi radius over time taken. Okay. This is for orbital speed. Okay. So here you can find an example, like here at like a planet just moving around the sun. Okay, and here if you want to calculate the speed, you can use the formula for speed. Speed equals to distance moving over time taken, right? And just put the circle's parameter into the formula, then 2 pi radius over the time taken. That is the orbital radius and orbital speed for the planet moving around the sun. Okay. And here is a very interesting question. Like here, I'll give you some numbers in here. And it's that like here the Earth's surface is about 560 kilometer, and the radius of the Earth is about 6,400 kilometer. Okay, so it completes one orbit 96 minutes. Okay, so flying is orbital speed. Okay. So here you can find, like here, the circle, like a black circle, it means orbital speed or like an orbit for the maybe satellite, right? So if you want to calculate the speed, also using the formula velocity equals to distance moving over time taken, right? Okay. So here we can say, oh, here the distance means the circle's perimeter, right? So here is the center of the circle, right? If you want to calculate the parameter, you have to use in 2 pi radius, right? So here radius, you can find it combined in two parts. The first part is about the radius of the Earth. Second part is about the the height of the satellite to the ground, right? So here is the 2 pi radius added with the height over time taken. Okay, here it is. So we can calculate that 2 times pi. Radius here is about like 6,400 kilometer, right? And also the height is 560 kilometer, and you have to remember all the time that kilometer has to convert into the meter. Okay, so here is times 10 cube meter. Okay, and the time taken here you can find is 96 minutes, right? So 1 minute equals to 60 seconds. We can say, oh, here 96 minutes equals to 96 times 60 seconds. Okay, so here is 96 times 60. Okay, so right here you can use the formula to calculate it. Okay, and finally you can find it a value meter per second. Okay, this is the orbital speed. Okay, so here is the exercise for you in the past papers. So trying to solve the problem first. Okay. Okay, so here you can find the Earth orbits the Sun once in approximately 365 days. The average radius of the orbit is 1.5 times 10^11 meter. Okay, and this question is, what is the average orbital speed of the Earth? Okay, so here it is. And we can say, oh, maybe here you can using the formula like speed equals to the distance over time taken, right? Here is distance over time taken. So here the distance means radius, like the parameter for the circle, right? So you can say, oh, it equals to 2 times pi times radius. So it's 2 pi, and radius here is 1.5 times 10^11 meter, right? And the time taken is 365 days, right? And it has a times for 24 hours. And also remember to convert it all the unit into meter and the second, okay? So here the seconds is 24 hours, and each hour we have 60 minutes, right? And each minute we have 60 seconds. Okay, so we have to using 365 times 24 times 60 times 60. Okay, that is the final answer and final calculation for velocity. So here velocity equals distance over time. It's this formula. Okay. So for this, we can set, oh, maybe here if we want to calculate the velocity, so always remember we have to calculate this like fractional number. Okay, so I think this is the final answer. We can use the calculator to find the answer. Not very difficult. Okay. So here is a second exercise, like also the same question like this. And said that a space station orbits the Earth at a distance of 7,000 kilometers from the Earth's center. Okay, so that means like there's an Earth, and here is a like orbit for a satellite, and here you can find the distance is 7,000 kilometers, right? And it makes 15 orbits in every 24-hour period. Okay, so we can set like 15 orbits in 24-hour period. So for one orbit, we can set that takes for 24 over 15 hour, right? Like taking for such number of the time. Okay. So time taken is such like this value, and we can using the formula to calculate it, right? Okay. And here the velocity equals to the distance over time taken. So distance here is 2 pi radius, right? So 2 pi, the radius here is from the center to the top. Okay, so we have to calculate here is 2 pi times like the radius here is from maybe 7,000 kilometer, right? We have to also times 10 cube after it because we have to convert kilometer to meter. Okay, that is it. And using the parameter for the circle and you can find t, time taken here is just like the 24 over 15 hours, right? For each hour, we have 60 minutes, and each minute we have 60 seconds. Okay, that is the final answer. And also, you can find this question is very interesting. You can find each unit is kilometer per hour. Okay, so we don't need to just convert it into meter and second. Okay, so you can just write down your like original number. Like here is 2 pi times 7,000 kilometer, and over here that is hour. So it's 24 over 15 hour. Okay, that is the final answer. I guess not very difficult, huh? Okay, so that is it. So here like 2 pi, I guess the answer here is about maybe for 27,000 kilometer per hour. We choose D. Okay, that's our final answer. Okay, that is for all today's lesson. I guess orbital speed is not very difficult for you. So you have to remember about the perimeter. It equals to the perimeter of the circle, 2 pi r, right? And also you have to call it the time taken. Okay, time taken for each question, you have to call it for one orbit time taken. Okay, that is for all today's lesson. See you next day. Bye.